And this is such a good example of it. In the shell, oh yes, it's still volume. Yeah, these are still volumes of solids of revolution. Volumes of solids of revolution. Say what?
Somebody was asking during pre-calc, they were like, what do you do in calculus?
I need you now to think, instead of slicing through with a regular knife or like with a little bread slicer where there's the two knives that come down and so each of your slices stays uniform. You know, if you're really going to slice bread nicely, you want them all uniform. Okay, today I need you to slice with more of a biscuit cutter. You know a biscuit cutter, you've got that little round thing and you go down like this in the dough and come up, and what you get is the whole biscuit. Well, I need just the shell of the biscuit. So my biscuit cutter actually has two kind of knife edges, but they're round, and when I slice down through and come up, what comes up looks like, it'll look like a soup can where the soup's emptied and the top and the bottom are off the can. So all you've got is the shell of the can. And the nice thing about this is we're going to take this thing and we're going to slice down through my shape, and the center of the shell has to go on the axis of revolution. So now when I slice down through, I'll draw you in two-dimensional. There's my slice going down through. And these are all based on the formula volume equals 2 pi RH. 2 pi RH. So our little volume here is going to be 2 pi times the integral. The radius gets measured from the axis of revolution out to your typical slice. So there's our radius. The height is the height of a typical slice, and that's going to bring you back to section 7.1. Sometimes you're going to have to do top minus bottom to get that height. On this problem, it's really just the, if this point is, yeah, it's just the y value. So we can fill in that the height of this is y. These are going to be little dx shells, and all I need now is an expression for the radius. If this is the point xy, the distance from here to here is x long. The distance from here to here is 6 long, so the radius is 6 minus x. And since our equation was y equals the square root of x, we can take out that x and put in, wait, y equals square root of x.
Y squared is the surface area of the cell? Yes, of that little section. I think.
He was saying 2 pi r, that's the circumference of a circle, right?
So it's like,
Yes, that is. That's the edge of my
so
biscuit
it's like
cutter.
if we open the cylinder and we're getting like the area of the
And lay it
rectangle.
down, and it's, yeah. 2 pi r is this length and then the height.
So it's like the area of the
Yeah.
right? Okay.
2 pi
I was
is the
thinking-
circle.
Do we not see something wrong here then?
Yeah, we have Y's from there since the years.
No, that was meant to do I see. I was
Oh,
trying to do the other.
darn, we've gone the wrong way, haven't we? It seemed like such a good idea, but these are dx shells. When you slide in this way, they're dx shells. So, sorry, this one didn't really help us. Let's see what we can do, though. Let's go ahead and leave the x the way it was.
I thought that was
And
surface area.
let's just replace that
Yeah,
y.
squared, that's what I-
So that's a square root of x.
2 pi RH is surface area.
2 pi r
Two
h.
pi r squared h is area, is volume.
Yeah, but what you're getting is exactly, that's what I was confused with. What you're getting is the area, like,
I'm
the
needing
surface area
this.
around the
And it's
cylinder.
got a little thickness to it, and that little thickness to it is what the dx represents. And these we're summing up, starting with a little teeny, it's not really a biscuit, it's only like the edge of the biscuit. And then I just keep adding larger and larger pieces of the biscuit until I finally got the whole biscuit. Only the whole biscuit does have a hole in it, notice.
Looks like a bagel.
Oh, you're right, more bagel-like. Only,
It's just not a
only
good class
flat
to
on the
have
inside.
during lunchtime.
Okay, limits of integration. Much easier than the last problem.
0 to
0 to
3.
square root of 3.
0 to 3.
The square root of 3 was the y value, but we're now in dx's. And the x's start here at 0,
And go to six.
and they,
3.
no, they stop at 3. So 0 to 3. Now, isn't that prettier than ick? Beautiful. So on the test, it's going to say for one problem, use disc or washer, and you're not going to have a choice. You got to do disc or washer. One's going to say shell, and then another one's going to say use whatever you'd like. So if you get, for me, when I get holes in them, I almost always go with the shell method because it's